Welcome to Statics Lectures by Civil Thinking, and today we are going to see another concept, and the concept is equivalent force systems. How to convert a coplanar force system into an equivalent force coupled system. Now before I move on, I suggest you to please watch the video lectures in sequence so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's class, converting a coplanar force system into an equivalent force coupled system. Now let me begin this problem. Let us say, for example, we have a body here, okay, and we have multiple forces on it. For example, we have a force here, we have a force here, and we have a force here at A, B, and C, okay. Let us say this is the point D. Now you can see all these forces lie in the same plane, so they are coplanar forces. Also, they do not intersect at a common point, so they are not concurrent. Okay, so basically we have a non-concurrent parallel force system, right? Now how do we represent all of these forces with the help of a single force and a single moment? Okay, now when we represent all of these forces with the help of a single force, for example, this is the force, this is the single force, and we have a single moment here. We represent all these forces with the help of only one force at point D and a single moment M. Okay, then we say this is an equivalent force coupled system. Okay, now we will see how to do that. What is the procedure to do that? What we are going to do, as I have already explained before, we will move each force to point D. If we want to represent the equivalent force coupled system of all of these forces at A, B, C, and if we want to represent it with a single force and moment at D, so we will move all these forces to point D. Okay, we will move all of these forces to point D, right? But when we move, we will also add the corresponding moment at point D. Okay, like this. Now we will move this force to point D, and then we will also add a corresponding moment, okay, due to this motion. Then we will also move this force to point D, and then we will also add up a moment. Okay, now this may seem all messed up. Don't worry, we'll be solving a problem on this and you'll understand everything. Then what we'll do, now we have multiple forces at point D. As you can see, we have multiple forces at point D. Then we will add those forces, okay, and we will also add, we have also multiple moments at point D. We will also add moments, okay. So we will get a net force, okay, when we add all these forces, and we will also get a net moment. Okay, now this force and this moment, this is the equivalent force couple system of this force system. Okay, so let us solve a problem on this concept so that we understand better. So the problem is on your screen. Find the equivalent force couple system at point D. Okay, now we have all these forces at A, B, E, and C. We have to convert all these forces into a single force system, force at point D, right? At point D, okay? And of course, there will be movement at point D too. So how we are going to do that? What we are going to do, as I have told you, we have to move all the forces to the point D, or we have to move the line of action of all the forces such that they pass through D. Now, as you can see in this problem, the force at A, it is the line of action of this force is already passing through point D, so we don't have to move this force. Now, look at the force at B. The line of action is already passing through point D, so we don't have to move F3 too. Now look at E. The line of action of F4 force is ED, right? And it is already passing through D, so we also don't have to move this force. Now look at C. The line of action of this force is CA, right? and it is not passing through D. So the only force which we have to move is the force at point C, and also we have to add the corresponding moment of F1 at D. Okay, now let's do it. Let us move the force F1 here. This is the force F1. Okay, this is F1 force. Now what is the moment of F1 at point D? Let me calculate here. Let us assume the clockwise moments, they are positive, and the anti-clockwise moments, they are negative. Okay, so what is the moment of F1 at D? So the moment is, it is going to exert clockwise moment, right, at point D. So it is 600 multiplied by, how far is 600 Newton from D? It is 500 millimeters. Okay, millimeters. So it is 600 Newton multiplied by 500 millimeters. Now 500 millimeter is 0.5 meters. Okay, 0.5. Okay, now when you use the calculator, let me use the calculator to find it. It is 600 multiplied by 0.5. It is 300 Newton meter. Okay, now when we move this force here, this is 600 Newton force, right, as you can see here, and the corresponding moment at this point, let me change the color first. The corresponding moment at this point is 300 Newton meter, right, 300 Newton meter. Okay, so let me erase all of this. Now we can clearly see we have multiple forces at point D, right, because the F2 force is passing through D, so it is, so we can say the force F2 is acting at point D. Similarly, the force F3 is passing through D, we can say this F3 force is also acting at D. Similarly, this F4 force is also acting at point D. Now we have more than two forces acting at point D, and remember the rule, when we have more than two forces acting, more than two forces, then we use method of projections. Method of projections. Now this method is quite easy. If you have not watched my previous lecture on method of projections, you can also watch, and maybe you don't need because I will explain it here. Now in the method of projections, we find the x component and y component of each force to be added. We have to add up all these forces, right, because you see we have to find a single force at point D, right, a single force. That single force, we will find it when we add all these forces at point D, we will get a single force. So to add, we will use method of projections. Okay, we will use method of projections. Now in method of projections, let us say this is x-axis and this is positive y-axis and this is positive x-axis. Now in method of projections, what we do is we find the x and y component of each force. Okay, then we add the x component separately and we add the y component separately. Okay, and then we get only two forces in x and y direction. Then because there are only two forces, when there are only two forces, we use what, parallelogram law of vector addition, right, parallelogram law. Okay, or we also use, right angle rule or triangle rule. Whatever you use, the results are the same. Okay, because then we will have only two forces, then we will use parallelogram law to find this single force. Okay, so let us first resolve each force into x and y component. Okay, now this F3 force, let me change the color first. This F3 force, let us say the F3 force is making an angle theta here. Okay, or theta, I will call it as theta B. Okay, this is acting at force B, so the angle here is theta B. Okay, so this is F3. From here it is going to be F3 cos theta B, right, and in the vertical direction, let me draw this. Let us suppose this is the vertical direction, okay, the y direction, and there will be the y component of F3, which is going to be F3 sine theta B, right. Okay, we have resolved this force. Now we don't have to resolve this force F4 because it's already in the x direction, so the y component of this force will be 0. Okay, now this F1 force, it is only in y direction, so the x component will be 0, so we don't have to resolve also this. Now look at this F2 force. Let us say it is making an angle of theta a. Okay, now the x component of this force is going to be in this direction, F2 cos theta a, and the y component will be in the up direction. It is going to be F2, sorry, it is F2 sine theta a, right? Theta a, right? Now I think we have resolved all the necessary forces. Now let us add all the forces in the x direction. Okay, let me write here, summation of f of x is the addition of all the forces in x direction. Now in the x direction we have F4, it is opposite to this direction, right? So it is negative. F4, as you can see here, it is opposite to this direction, so F4 is negative, so it is minus 760 Newton. Then we have, this is F3 cos theta b, it is towards right, so it is positive, plus F3 cos theta b. Okay, then what we have now, F2 cos theta a, it is in left direction, so it is negative, right? Minus F2 cos theta a. Now is there any another force in the x direction? Let me check. This is F4, we have already written F4 760. Now we have F3 cos theta b, we have F2 cos theta a. Okay, that's it. I think we have added all the forces in the x direction, so we have to add them up. Okay, now let us first find theta b and theta a. Okay, now from this triangle BDE, from triangle BDE, this is a right angle triangle, right? Now when you apply tan theta, okay, tan theta is what? Perpendicular divided by base, right? It is 375 mm divided by 200, right? Now this is theta b here, tan theta b. Now from here we will find the value of theta b. It is equal to tangent inverse of 375 divided by 200, right? So let me use a calculator to find the tan inverse of this thing. Tan inverse of 375 divided by 200. Okay, it is 61.93. 61.93 degrees. Okay, we have the theta b here, 61.93 degrees. Okay, similarly we'll find theta a from the triangle ACD, right? From triangle ACD we'll get theta a from here, right? Now theta, let us apply tan theta a here. It is equal to, perpendicular is AC, which is equal to BE, which is 375. Now the base of this triangle is CD, which is 500. Okay, so it is 500. So I will get here theta a to be tan inverse of 375 divided by 500, right? Divided by 500. Okay, so let me use a calculator to find the value. Divided by 500. Okay, it is 36.87. We get the value of theta a to be 36.87 degrees. Okay, so let me erase all of this first. Now when we find the value of cosine of 61.93 degrees, okay, so let me find the value of this cosine of 61.93. it is 0.47. okay, so this cos theta b, all of it is 0.47. Let me also find the cosine of 36.87. Cosine of 36.87, it is 0.8. Okay, this is 0.8. Okay, so let me write here, summation of f of x is equal negative 760 plus, now f3 is 340, right? 340 multiplied by 0.47, right? Then we have negative f2 is what? F2 is 500 multiplied by 0.8, right? So let us use a calculator to find the value. Minus 760 plus 340 multiplied by 0.47 minus 500 multiplied by 0.8. All right, I get summation of f of x to be approximately negative 1000. Okay, of course it is Newton. So let me write here, I got the value of summation of f of x to be negative 1000 Newton. Okay, now negative means what? Negative means opposite to this direction, so I will erase the negative value and just write an arrow here in this direction. Okay, now in the same way we will find the summation of forces in the y direction. Okay, all of these forces in the vertical direction. Let me first write the value of theta b and theta a2, because we will be needing this value when we find the forces in the vertical direction. So let me write here theta b. Theta b is this 61.93, and theta a is 36.87 degrees. 87 degrees. Okay, that's all the information we need, and let's erase all of this, and then we will find the summation of forces in the vertical direction. Now let's find the sum of all these forces. Let us add up all these forces. Okay, they are vertical, so summation of forces in the y direction. Now the upward forces are positive and the downward forces are negative. Now f3 sine theta b is upward and f2 sine theta a is upward, so they are both positive. f3 sine theta b plus f2 sine theta a. Now what other forces are in vertical direction? As we can see here, we have a force of f1 here, which is upward, which is 600 Newton plus f1. Okay, let me see if there is any another force in the upward direction. Okay, now f3 sine theta a theta b, I have written that. f2 sine theta a, I have written that. Now this f1, I think we have only three forces in the upward direction and we have written all of them. Okay, now let's put the values. Now f3 is 340 multiplied by sine theta b. Sine theta b is 61.93 degrees, right? 61.93 degrees plus f2 sine theta a. f2 is this 500 multiplied by sine of theta a. Theta a is 36.87 degrees, 87 degrees plus f1. f1 is 600 Newton. Okay, so when we use a calculator, we will find the value of summation of fy. Let me use a calculator. It is 340 multiplied by sine of 61.93 plus 500 multiplied by sine of 36.87, right? Then we have plus 600. Okay, I got the value of 1200 Newton. Okay, now I got the value of summation of f of, let me erase this first. Let me write here, summation of f of y is 1200 Newton, right? Since we get a positive value of 1200 Newton, and the positive are in upward direction, right? So it is in upward direction. Okay, so let me erase all of this first. Now let me draw a neat diagram here. Let me draw a diagram here. Okay, now this was our point D, right? Now at point D, let me change the color first. Now we have a net force in the x direction, 100 Newton, towards left, right? 100 Newton. Then we have 1200 Newton upwards at point D. This is 1200 Newton, right? Now there are only two forces and they are perpendicular to each other, right? Now the resultant will be somewhere between them. Okay, let us say this is the resultant. Okay, the value of resultant is square root of 1000 square plus 1200 square, right? Now let me use a calculator to find the value. Okay, the resultant is approximately 1562 Newton. Okay, so the value of this resultant is, let me write here, the value of this resultant is 1562 Newton. Okay, now let's also find this angle. Okay, let me call this angle as beta. Then we know the value of beta is what? Tan inverse of 1200 Newton divided by 1000 Newton, right? Now Newton and Newton will cancel out, so let me use a calculator. Tan inverse of 1200 divided by 1000. Okay, it is approximately equal 50.2 degrees. Okay, so this beta is equal 50.2 degrees. Okay, so we can erase everything here and we'll just write this resultant here, which is 1562 Newton, and it is making an angle of 50.2 degrees. Okay, now this is the, we have to find the equivalent force coupled system at D. Okay, now we found the force, this is the single force which we wanted to find. Now let's find the moment. Okay, now as you can see here, the only moment at point D is 300 Newton meter clockwise, right? There is no another moment. Now if there were multiple moments at point D, okay, then what we would do, we would sum up all of them. Okay, now since we have only one moment at point D, so the summation of moment at point D is 300 Newton meter clockwise. Okay, so moment at point D is 300 Newton meter clockwise. So this is the equivalent force coupled system of this parallel force system. Okay, this is how we solve the problem. Now if you have any doubts, you can comment, and please give me a thumbs up if you like. I generally never ask you to like my videos or subscribe to my YouTube channel, but now I request you to please subscribe to my YouTube channel because I have way too little subscribers. Okay, so I need your support if you got some value from my class. And that's it for today. See you in the next class. Thank you.